All right, I want to welcome Jeff Jalbrzikowski today from NOAA. He's going to be our presenter for the Eureka Texas Speaker Series for September of 2021. I'd like to thank our co-sponsors, Nearmap, Consortec, Tenorus, Altera, Dunaway, for sponsoring the speaker series. We always appreciate that. We got a great presentation here today. Jeff is going to talk about the geodesy for the modern age. Jeff is a part of the Appalachian Regional Advisor for NOAA's National Geodetic Survey, the NGS. He's got a lot of experience. He's a licensed professional surveyor in multiple states, certified GIS professional, a certified floodplain surveyor, and so on. So, Jeff, we want to thank you for being here today, and looking forward to a great presentation, and take it away.
All right, hey, thanks, Brian. Sounds like you can hear me good. I'm going to switch my window over here to my PowerPoint, and I believe you guys could see my title slide there. So there's my contact info at the bottom of the screen. If you end up with follow-up questions or whatever, feel free to reach out. And if you have any questions as we're going along, please go ahead and type them in the questions box. I'll either try to work that in, or we'll get to them at the end. So yeah, let me know what your questions are. I'm just getting my screen settled here briefly, and I will move on to my next slide. There's a little bit of my background that Brian already shared. Yeah, that's pretty much. University of Akron is where I got my most of my education in surveying and mapping. Also did a little bit of schooling in surveying cartography when I was in the Army. Go Zips, I'll say, for U Akron. And today I'm coming to you live. I'm broadcasting live from the basement of the Alamo. Just kidding. I know there is no basement in the Alamo, right? I've seen the movie. Anyways, I'll move on. That joke's probably been done too many times, right? Let's talk a little bit about NGS to give you some background about who we are at the National Geodetic Survey. So we're a part of NOAA, and here we are on that kind of little org chart chain there. So we're a small group. We hover around 175, typically less than 200 employees. We're part of this National Ocean Service, which is then part of NOAA, the National Oceanic and Atmospheric Administration, which then is further a part of the Department of Commerce, which is about 50,000 employees right now. So we're like less than 1% of the Department of Commerce. But we are, believe it or not, the federal government's oldest civilian scientific agency. We've been around since 1807. And you might think it's weird with our current mission, right, of what we provide and what I'll talk about, that we're part of the Ocean Service, but really it goes back to our history. When we first became an office in 1807, we were the Survey of the Coast. Initially, that was our main task, was to map the shorelines, both east, west, and the Gulf of Mexico of the United States. But somewhere around, I think it was 75 years ago now, we were tasked with furthering that mapping, or the geodetic control part inland. Okay, so we've been doing that for a long time. And when I talk about who we are, I like to real quick talk about who we're not, because there's a lot of, I've heard a lot of confusion. People call me and, hey, USGS. And I say, well, no, I'm not USGS. That's the United States Geological Survey. So we're totally separate. They're part of the Department of Interior over here. But we work closely with folks at USGS. It's just I've heard this misunderstanding, and I think it might come from some of our older names. We've had a lot of different names in the past. One of them was the U.S. Coast and Geodetic Survey, and that the acronym, sounds really familiar to USGS, right? So totally separate office, but they do good work too. So what's our mission, right? Right there on the screen, you can see the important part is in red, right? Define, maintain, and provide access to, and we'll talk a little bit about really all three of those: defining, maintaining, and providing access to the NSRS, or the National Spatial Reference System. What is it? It's our official national coordinate system, really. It's the foundation for transportation, navigation, land record systems, the mapping and charting like that USGS does, charting that NOAA does, river charts that the Army Corps of Engineers puts together. These are all tied to the NSRS. Really, if you think about what you do on a regular basis working in GIS, the work that we do, not just NGS, but we as in geospatial professionals, it would really be, I don't want to say impossible, but it would be so much less efficient if something like the NSRS didn't exist, right? So what are we? What's the NSRS? Again, if you've seen this graphic, you probably have seen it in some form. That's our mission right there. The NSRS is to build and maintain that framework data set and then somehow provide access to it. And so nowadays, or historically, we provided access, right? These little, these triangles here, those are those benchmarks in the ground, those discs you'll see set in concrete or set in the side of a building. That's the access. And that's the big thing that's going to be changing as we move forward into our modern era, okay? And so if you attended the GIS Pro, ERISA GIS Pro, I think it was last year, our director spoke at GIS Pro, and she had this slide in there, and I really liked it. So I borrowed this from Juliana. She talks about what geodesy is, right? And I'll kind of let you absorb all that wording there, but really it's the shape of the Earth, right? And not just the fact that it's spherical or semi-spherical, right? But the gravity that affects that shape. The other planetary or other space bodies that affect us in Earth, right? And how all of that changes and interacts with each other over time, okay? And so our big product for many years, right, the NSRS was initially started back in the 1800s, and it was doing very old-fashioned surveying work, triangulation typically. That's what you see, these lines connecting dots, and it was all on the coast back then. As you move forward, the next century into the early 1900s and even into the 50s, 60s, 70s, 80s, there was still a lot of that conventional type of surveying where you'd see a point, and then triangulation, towers are set up, telescopes are out, really into the early 80s. But today, if you take a look, so this is really the same area of New Jersey, these three graphics, but now all of that work, those lines that you see sketched in here, there's no lines of sight anymore. Really, all we use is GNSS, okay? And what's GNSS? Just global navigation satellite systems, a more generic term for GPS. GPS refers to our American constellation. GNSS just means GPS and or others, okay? So that these lines on our maps that we have out today, they represent a whole different thing. It's all GNSS. And so again, that to clarify the NSRS, people really aren't familiar with this term. I really hope that folks do become familiar with it, especially as we move forward with doing some of our maintenance on it. The common and consistent geospatial framework, I really like that wording, right? And some items you'll see that are part of it, these horizontal and vertical datums up the top. Hopefully these are familiar to you, NAD 83 and NAVD 88. And you'll see some other water level, vertical water level datums like the Great Lakes datums, IGLD. Probably not something you're ever going to use in Texas. If you are using it there, I hope it's for a client in Ohio or Michigan or something. Otherwise, you're way off base, right? Geoid models. That's another product of the NSRS. The geoid model is what allows you to take your GPS or GNSS-based data and put it into a vertical datum, okay? That's what your geoid model is. And our newest geoid model is Geoid 18. But the foundational elements of the NSRS that we go on to use to build these datums are really right here. Our latitude, longitude, and height, or what a lot of folks and even myself will call elevation, okay? There's also that gravity in the background that deals a lot with the vertical datum, and then our shoreline positions that's still really part of our mission today, and how those change over time, right? But what I want to highlight, a couple other things about this. So here's a full list of all those datums, right, that are part of the NSRS. Not going to be on the test, but just there for you to see. And what I want to highlight really is just a couple things that are not part of the NSRS. And I really want to highlight that WGS 84. Okay, a lot of people are nowadays I hear, well, I use WGS84 for everything. You really need to be careful with that because as we talk, you'll see there's different versions or realizations, as we call it, of NAD83. And there are also different versions or realizations of WGS84. And there's not a really well-defined relationship between those realizations of WGS84 and NAD83. So I'll caution you, if you think you're working in WGS84, you really might want to take a look at that or reach out to myself or one of my cohort regional advisors, okay? So do you have to use the NSRS? I get that question a lot, so I throw it in here as a slide. No, you really don't. It's a great idea, right? Your data that you can download from state agencies or USGS 3-depth data, right? Aerial photos that you're downloading from TxDOT, other states that you're working in, aerial LiDAR data, all that is typically tied to the NSRS, right? It's in NAD83, perhaps the state plane coordinate system, but that too, as you saw in a couple slides ago, those are part of the NSRS, right? Some jurisdictions mandate the use of it, not too many around here, not sure about places in Texas. A quick note that any federal spatial data or GIS activities that have any federal funds, they are required to be tied to the NSRS. And I put that in there because it kind of leads to this last item, right? If you want to get involved in contracted work with the federal government, right? The Army Corps of Engineers, I used to work there. We were talking about that before today we got started. That's really, you're really going to have to embrace the NSRS in all of your products and all of your deliverables, okay? So we talked about the foundational elements. So now we look at the positional components of the NSRS, all right? Two main, you see there is your geometric and your geopotential. Most of today, I wanted to cover both today, but kind of looking at my time, we're going to mostly focus on the geometric. If you saw my presentation last year at ATX GIS Day, I focused on geopotential, so you could go, maybe it's out there online somewhere. But today we're mostly focused on geometric, or what you might say horizontal. The reason we refer to it as a geometric is because not only is your latitude and longitude a part of your geometric position, but so is your ellipsoid height, okay? That's the native height that GNSS or GPS is going to give you, is an ellipsoid height. You would use that geoid model, right, to convert that to an orthometric height or elevation, all right? So geometric today, most of the focus is going to be on NAD83, our current geometric datum, or the North American datum of 1983, which will be replaced by what? The North American Terrestrial Reference Frame of 2022, or as we call it, NatRef, right? We made the acronym, we can tell you how to say it. So NatRef, right? I see a question that popped up. I'm going to address that a little bit later because I see that a similar question a lot. I didn't read the whole thing, but I will take a look at that a little bit later. And so I do want to pop this up because a lot of times I talk about latitude, longitude, height. People say, well, hey, Jeff, I do all my work in state plane. These new datums, doesn't matter to me. I always have to think and talk to that person. I say, well, look, I try to, we got to be courteous about it, but it's, where do you think those state plane coordinates come from, right? Every SPCS 83 coordinate initially comes from an NAD 83 coordinate at some point, or it can be transformed or converted to one, right? And then the same will go for SPCS of the future, the 2022 version. It will be based on, tied to NatRef 2022, okay? So it's really something to think about. Don't get stuck in that evil thinking loop of, I don't need to worry about it. I work on a planar surface. It's still going to affect you, okay? So I'd like to talk about a little terminology here in the beginning. I think as we move on, you're going to be like, oh, wow, that helped, right? So terminology, we hear this datum a lot, and I've heard a lot of people think different things of what that really means. But if you really dig back to when folks started using the phrase from a geospatial perspective, right, it can be used in other ways. The Latin original term, was something given, right? Something that you take for a fact, right? And so we use the term, this was an old document I dug up from like 110 years ago. So it was a predecessor to NGS, gave this phrasing, the adopted standard Latin long of a station, right? A mark in the ground, together with the adopted azimuth of a line from that station to another station, right? And so if you're familiar with NED 87, that would be the stations Meads Ranch in Kansas and another mark in the ground that's designated Waldo, okay? So it's basically 2 points connected and a 0 point and a point that's sighted from there, and that's called 0, right? That's a datum or a horizontal geodetic datum, okay? So for NAD 27, we are specifically talking about that mark in the ground there, Meads Ranch out in Kansas. And you probably are familiar with these discs in the ground. That's what I'm talking about. That's our means of you, our users, our constituents, our stakeholders accessing the NSRS, okay, or these marks in the ground, right? And that mark, it's still out there somewhere. You can find it. I've stopped at it. I won't go into that long story before at this point, but you could think of that as, you know, that's the origin of NAD 27, right? And so what happens from there when you decide, you pick that origin and you propagate, right? So you've chosen those 2 marks. Lost my little highlighter, right? You cited that one and called that 0, and now you propagate that datum further, right? And then further, right? And then a little bit further, okay? And how was that done? Really, it was done with those towers I talked about, right? Where there's an instrument, a telescope set on top of this really tall tower. Another one here with a gentleman climbing on it. A couple others. So there's an example of an old instrument that would have been used. And this one's pretty neat. It's actually not on a tower, one of these built towers anyways. It's on the top of a water tower, looks like. So this was kind of a sight line of opportunity. They just lashed their instrument to the finial there. Another type you might see would be an old dead tree or used for the instrument. And then the gentleman here standing on a tower erected next to it, okay? So that's how, missed a slide, that's how this whole network was propagated. And the problem with that is twofold, right? You get error buildup, okay? Each time you do those sightlines as much and as perfect as you want to be, you're going to get error buildup, okay? And so that's a pretty big weakness of the system right there, is that every mark out here is then going to have some error as you move along. So the access I talked about, right, to the NSRS, it is those marks in the ground, right? The disks and various other things that you'll see used as benchmarks or survey disks, whatever your preferred terminology is. And those are information on those that's stored currently in our NGS integrated database, or IDB. Here you'll see integrated because there used to be 2 separate books or files of information, horizontal on one side of the office and vertical on the other side. And sometime in the late 70s, they said, wow, this makes no sense. Let's combine it all and put it into a computer. So it became the integrated database. It's our database of all official published geodetic control. It's delivered out in the form of data sheets, if you're familiar with that. And believe it or not, there's like 1.6 million marks in the IDB, and it is a non-spatial database. Okay, all of the spatial facets of it that are used nowadays to plot those marks on our web maps, it's all was coded later on through non-spatial queries. So it's crazy to think over 1.5 million records on spatial data, but it's in a non-spatial database. So part of our future goal, we've already got some drafts done, is to create a new database for the future, right? As the NSRS database will be the name. We'll provide it via a data delivery system. So not just these static PDFs or text files you can get from us, but we're talking JSONs, XML data, direct connections to our database, hopefully, working through APIs, various options for us to deliver that data to you, our constituents, okay? And it's being designed from the ground up to house geospatial data, so completely starting over in our database. And kind of back thinking about the traditional horizontal datum and the drawbacks, you've got that error buildup, right? When using those old telescopes, theodolites, transits to site your survey marks in the ground. The other problem you run into is that you'll end up using a reference ellipsoid that's optimized for a certain region. So in this little graphic right here, you see NAD 27, right? The reference ellipsoid used to build that datum aligned very well, right, to the topographic surface of the Earth in the continental US, right? But if you look over here on the other side of the world, it's way off, right? So, and the same could be said for the European datum in 1950 down here. You know, it aligned in certain areas to the continent of Europe very well, but to other areas of the world, way off, right? So they don't coincide with the center mass of the Earth, all right? Why does that really matter? Gravity, okay, center of mass, gravity. Why does gravity matter? Well, future vertical datums will be built off wholly gravity-based. Still, you might be thinking, why does that matter so much, Jeff? It's the satellites. Remember what holds satellites in orbit? Gravity, right? We're all working with way more satellite data than we did 25 or 35 years ago. So it's become really important to use center mass of Earth-based datums, or what we've moved away from even calling them datums in the most part, and we're moving towards using the proper terminology that's been around for a long time, but we didn't really use it, is a reference frame, okay? Is a more scientifically appropriate term for that horizontal or geometric datum. Nice little definition there from like a physics textbook, right? System of graduated lines symbolically attached to a body, describe the position of points relative to the body, right? You probably even use that terminology in college physics. But let's think of it some other ways and try to break this down. Point of view, frame of reference, right? Pretty simplistic way of thinking about it, right? So if your reference frame is North America, like it will be for NatRef 2022, you need to be imagining yourself standing somewhere within North America, as a lot of us are right now, and you're seeing how other places move from your point of view. You're imagining yourself not moving, even though we know we're moving on those tectonic plates, and you're observing how other things move with respect to your point of view. So that's NatRef 2022 in a nutshell. So the thing about a reference frame is before you can actually realize it or provide access to it, which is what we do, you have to define a reference system, and that's the NSRS, right? What is a reference system? I'm going to go over it real quick with these bolded letters right here. The reference system is the recipe. So right here, you're talking about my Aunt Till's Tipsy Pound Cake, right? Very delicious, right? That's your reference system, the recipe. The reference frame is the pound cake when it's made and doesn't look delicious, right? That's the best, that's really the easiest way you could think of it. I heard this from a colleague of mine, okay? But what does that mean to us in the geospatial arena, right? So the reference system is the axes, whether it's a 2D XY or a 3D in this case, right? X, Y, and Z axes, that's the reference system and the grid attached to it, right? The reference frame are these stations out there all over the continental United States, all over the United States and territories that we place out. This acronym, if you're not familiar, it's CORES, and I'll talk about that in a second. And the CORES are what we use, the continuously operating reference GNSS stations, are what we use to provide access to modern reference frames, okay? Instead of just those marks in the ground, you'll have these CORES. Where's this all going, you're wondering, okay? So there's an international, global, worldwide network of CORES, right, called the IGS network, shown here. There's also, and there, if you take a look right there, that's our network, the NOAA CORES network. So let's kind of zoom in there, showing the lower 48, and then Canada, US territories, and some other global networks that we have. And so these CORES, these stations, there's over 2,000 of them in the NOAA CORES network, or the NCN right now. Texas is peppered with CORES. TxDOT does a fantastic job of maintaining a CORES network. It's very dense. It's a well-placed network. It's been around for a long time. And along with TxDOT, there's 200 some other organizations that do contribute to the NCN, or NOAA CORES network. There's a little dashboard on our page you can check out. This is a capture from a few weeks ago, so there's the actual numbers. So what is a CORS? Maybe you just really don't know. So there's the acronym, continuously operating. We kind of skipped the GNSS part. It's just become part of, whatever the word is I'm looking for. But yeah, so we just say CORS. What's there? Well, you got a GNSS antenna on some sort of mast or mount affixed to, in this case, the ground, a little cartoon earth, or maybe a building, or some sort of anything, right? And then attached to the GNSS antenna via cable, you're going to get a GNSS receiver. You got to have that. You got to have something to power this thing with, and you got to have something to store that data, because these things, the idea is they're continuously operating, right? They're running 365, 24/7. Now, what makes them really modern, a lot of systems have right now, is they also have communication, so that data can be served out. Nobody has to go drive out and collect the data. It's served over the internet, cell modems, etc. Continuously operating reference stations. Okay, those are the 365, 24/7. So when we talk about a reference frame and we talk about NatRef, we kind of need to talk about a couple other items or a related system. So the International Terrestrial Reference Frame, which does have an underlying reference system. We don't need to go all the way into this, but just behind the ITRF is the IERS, International Earth Rotation Reference System, right? What is this International Terrestrial Reference Frame? I thought this was America, Jeff, and NatRef, you said. Well, they're going to be closely linked, okay? The ITRF, there's a great definition from the ITRF there, from the agency there. There's a pretty good definition, right? Accurate, stable set of station positions. That's the key word here. What kind of stations? CORS, right? Among some others, but mostly today I want to focus on those CORS. And here's the definition I really like, makes sense to most people. Approximately represents the motions of the tectonic plates with respect to the Earth's deep interior. Huh? I got a great animation. It's going to click for you, I think. There it goes. You'll see my note here, watch the grid. The ITRF, the concept is pretty much this graphic. You see the grid stays fixed, right? While the tectonic plates, the continents move around, right? You can see I've highlighted this down here, epochs, right? So this is highlighting the tectonic plate motion of how many millions of years or whatever, right? So looking at epochs passing, the grid stays fixed, the Earth's surface shifts around, okay? You might not be familiar with that term, epoch, though, right? So let's take a look at that. It's really a terminology about time or the fourth dimension, okay? You could say epoch, epoch, tomato, whatever, okay? But the important part is you understand what it means. It's an instant of time, okay? Astronomy and geodesy use a decimal date, so you'll see decimal dates like this in our geodetic database and our information. There's a close ties between the geodetic and astronomic sciences, and astronomy's been around even longer, and that's what they use. So that's what we use in geodesy. But you don't have to use a decimal date for your system, right? Whatever you want to do as you start looking at maintaining epochs in your data, it's fine. We're not the datum police. We just want you to start adding dates, epochs of some form to your metadata, right? So incorporating epochs is important, not the format you use, as long as you know what you're doing. But it is important that you understand this is what you'll see in our data and a lot of other geospatial information. Others use a day of year with a colon. Some use a day of year with a period. So you just need to start understanding it. But really, a calendar date is sufficient for most GIS data sets. Okay. Where will you see an epoch in some of our information right now? This is an example of one of those data sheets I talked about earlier from the NGS IDB. You will see a decimal epoch on all of them for NAD83. The current realization here being 2011. What you see in parentheses is that realization. Okay, the epoch over here is 2010.00, or what that translates to is January 1st, 2010. Okay. Oh, I must have accidentally moved a slide. I intended for another one to be there, but we'll move on, and hopefully it's in there somewhere. So when we talk about changing coordinates, right, believe it or not, there's actually some official or somewhat official terminology out there, and we're going to try to use the proper terminology. We've kind of gotten away from it over the years, so we want to kind of push it to everyone, and as we move to using it properly in all of our websites, our anything we publish, and our software and tools. So a conversion is when you change the type of a coordinate, okay? So going from lat-long to state plane coordinate system, or SPCS, right? See, you get the same datum, the same realization. That's that 2011 is the realization of N8083. And again, same over here, but lat-long to state plane. That's a conversion. In green, you see a transformation is when you change the datum of a coordinate. So in this instance, moving from N8027 Latin long to N8083 Latin long. That's a transformation. Same will be for N8083 2011 realization to NatRef 2022 Lat long, okay? Well, what about, as we start talking about epochs, what about when we change the epoch of a coordinate? There's a word for that. It's an ISO standard, believe it or not, if you're familiar with ISO or ISO. It's a propagation, okay? So if you're working in the ITRF, epochs are extremely important because that grid is fixed to the Earth's deep interior. It lets you measure all land surface motion wherever in the world. So changing the epoch of a coordinate from this 2019 dot something to ITRF 2014 epoch 2021 dot something, that's a propagation, right? Because here you see the same reference frame ITRF 2014, right? Here and here, it's the epoch that's different, okay? That's a propagation, all right? Where will you go in the future when NatRef requires you to do the same thing in ITRF, right? You'll need to know the epoch of your data sets and sometimes the actual features within the data, depending on what your needs are. Where will you go to do that? Well, we have a tool that already exists that will be expanding to include that component of propagation. It's called the NGS Coordinate Conversion and Transformation Tool, or NCAT. There's a single point conversion on the base web page that you can use to just kind of play with it or drag this dot around or key in a lat long, go ahead and do things. Not very useful to the GIS community. The multi-point conversion is just the next tab over. That allows you to upload an ASCII text format as shown on the page there. It shows you how to set up your file. Same options though to do horizontal and vertical transformations and conversions through all of the different NSRS datums, horizontal and vertical. Along with the multi-point conversion, what might even be better for you probably is our web services, right? So if you click that tab, you end up here on our NGS Web Services homepage, because we have more than just the NCAT web services that are out there already and some folks are using. We have APIs for geoid heights, some gravity information, our Data Explorer, which is how to find those data sheets, the survey marks on the ground, and then there's NCAT, VDatum, and Opus, right? We have descriptions of how to input to the web services on that page. And here's just the output from an NCAT datum transformation that I ran. You're probably familiar with type of JSON output. Another great thing I want to highlight to the GIS user community, it's pretty new. Maybe, I think I cut it off at the top, the header. If you don't recognize what this, anybody know what this website is? Type it in the chat. It's GitHub. So we have a GitHub page now, all right, with all of our code. Our NCAT code, the code library is on GitHub right now, and we will be expanding our GitHub page as things move into the future so that folks can go and use that code to do whatever it is further that they want to do with it. And you do have another option besides NCAT, right? Something else you might want to check out if you're along the coast of Texas is VDatum, okay? It stands for vertical datum. And here's the website to find it, vdatum.noaa.gov. What makes it different than NCAT? Really, it has more transformations in it, okay? So it includes those water level transformations you might need, like mean low or low water, mean high water, ordinary high water. All those different coastal water level datums are available in this vertical information tab within VDatum. This is the online version of VDatum at this website here. The download version is downloaded. You have to have a certain version of Java to run it, but it's downloadable. It's pretty big download, some gigabytes, whatever, but it includes all the files you'll need. And here's an example. I was running a water level transformation. Cool thing about the download version of VDatum, it also supports LAS files, Esri rasters, shape files, geotips, and ERDAS imagine files. Okay, so VDatum's pretty neat. VDatum also has some really good information on WGS84 and how it ties to the ITRF. So if you are working in WGS84 or whatnot, VDatum is a really good source. It's hard to find good sources of how to relate different realizations of WGS84 to NAD83, but VDatum will get you there, and it'll also explain those relations of WGS84 to the different ITRF reference frames. Sorry, I slipped on my mind there. So as we talk about replacing NAD83, there's really 4 aspects to building NatRef. We're going to build 4 reference frames. Why 4, Jeff? What's the deal? Well, here's the 4 reference frames that we'll be building. And that's because there's 4 tectonic plates in our area of responsibility, right, across the US and all of our territories. Great thing is, these plate fixed reference frames, which we'll define later, if you're working just in Texas, you'll only ever have to worry about NatRef 2022. Unless you're out in coastal California, you're not really going to need to know about anything else. Then we're going to have to align the current NAD83 to ITRF in 3 dimensions, which is a pretty simple aspect by way of cores data, right? What have we learned with all these satellites up in the atmosphere, above our atmosphere, flying around the Earth? We've learned that NAD83, the origin that we chose for it, it's not as accurate as we wanted it to be. It's away from the center mass of the Earth by over 2 meters. So what we're going to do is we're going to shift it on over, align it to ITRF 2020, and that will make NatRef 2022. Okay, notice we use the same reference ellipsoid. We just tie it to a different origin point. That's aligning in 3 dimensions. Now we have to, if you remember that ITRF, it's a dynamic thing because the tectonic plates are dynamic in it, right? That animation we looked at earlier. So we have to pick a certain epoch and align to it, right? So let's look at it this way. Zoom in on the lower 48. So the ITRF, if you think about it this way, it's a constant frame with a rotating plate, okay? So in blue is the ITRF, and this is how the United States would look over tens of thousands of years or whatever, right? It'll be rotating counterclockwise somewhat, okay? Constant frame with a rotating plate. And what NatRef's gonna look like, it's a frame that is rotating constant with the plate. So it's like this, okay? So that's NatRef. That's really the big difference. And that's why we call it plate fixed, okay? It's fixed to that plate. Last step of replacing NAD83, we want to remove the tectonic motion from ITRF, okay? That's with that plate fixed term we talked about, right? We're going to use 2 things, these Euler pole parameters. Don't worry about pronouncing it. It's Euler, EPP, think of it that way, right? So here's these Euler poles and plate fixed. What does that all mean, right? So this is our, we're going to look at another graphic. Let's just skip to the graphic, forget about the words, right? Let's go, boom, here we are, okay. So again, this is the same set of graphics, ITRF versus NatRef this time, though, so you can see them at the same time. The green here is what represents that EPP, or those Euler pole parameters, okay? What we're doing is we're building these parameters to be able to model out that tectonic motion and have our grid fixed with the plate. That's what we call it, plate fixed. Okay, what's important there is you can't do that without a lot of cores data, those cores that are all over the continent and all over the world. Without them, it wouldn't be possible. There's no more of just picking a point in the ground, sighting another point. That's the datum. No, we all want to align to that center mass of the Earth. Benefits of satellite data are better correlated, and so on and so forth. So we use that Euler pole parameters, this green here, to walk between ITRF and NatRef, okay? The important thing, if you think about it, the one thing you got to know, the one super important piece of metadata to switch between those two is the epoch of that feature or that data set. Okay, without knowing the epoch, you can't really use the EPP. There's another portion called this IFVM, or intra-frame velocity model. It gets a little bit dense here. The important thing, let's look at, the point, I'll just skip to the chase here. I kind of want to move along, is that the goal of the IFVM, you can see if you plot the position of a point, it still moves even when it's plotted in NatRef versus ITRF, because we can't model out all of that rotations. There's some motion still left. The rest of that motion will be modeled out via this IFVM, the goal being a flat orange line, right? So if you plot the position of that point, there would be no motion. Kind of like that guy from that band Puddle of Mud, right? Can you take it all the way? That's what we want to try to do with the IFVM. It's a tool to build upon and kind of take all that land motion out of your data. All right. The thing you got to remember is there's still some drift. That's why that IFVM is like the last step if you're really trying to get super accurate data, because everything in the world moves. Coordinates with NatRef will be associated with the date your data was collected, so you must know your epoch. The IFVM goal is to then be able to align data, right? That's what you do a lot in GIS. That's the goal of the IFVM, is to be able to apply it and determine any of those regional land motions that have affected your data. That's pretty, in a nutshell, kind of the NatRef 2022, right? So I want to focus on one more thing and then get to kind of some preparation thoughts, right? So let's think of an example. And this slide might be overload, but that's why I want to highlight how complex this will be and how we're going to make it easier for you. So picture it's 2039, and you're working with some data near San Diego for some reason, and then the data is in NatRef 2022, right? You've got a client over there, and you want to use another data set. Oh man, this is great. That's perfect from my analysis. Oh, it's from a few years ago. It's from 2028. No worries. I know the epoch. I can propagate it, right? But you found it's in a different reference frame. It's in that Pacific terrestrial reference frame because it's in San Diego, coastal California. How would you solve that? You'd have to take one path, maybe this way across, or one path down this way, of walking through all these steps, and oh my gosh, right? Don't worry about it. We're going to give you Ncat, right? That's the whole beauty of Ncat. You'll use it whether you use the web service, you download the GitHub code to build your own thing, whatever. Ncat will do all of that convoluted stepping through for you, okay? So I put all that up there to try to hopefully make you, and VDatum will do the same thing. That's the thing. We provide all of our Ncat code to the VDatum team, and they take our code and they have all the water level datums and they combine it. That's really what VDatum is, you know. So remember, thinking about this as we move forward, what's the goal for NatRef 2022? Give you the stability, right? Take away all that motion. How do we do it? With those cores, that cores data, all that GNSS data. So how do we prepare for this? There's two factors you need to think about right now as we move to the future that will dictate your frequency of coordinate updates, right? Your how epochs will affect you, your data sets, your accuracy needs, and the region you work in, or how much tectonic motion or land motion do you see there, right? So it's like, think about it. If you're mapping out manholes, do they really need centimeter level updates, you know, every year or something? In most of Texas, I imagine not, right? If you've got within a foot or two, you're going to find that manhole. Even if you magnetic locate, you're going to find it, right? But if you wanted to do that, we will give you the tools to do that. Ncat will be there for you via the various offerings, formats of it. But the important thing I want to point out is that we are the ones that are chasing that millimeter, okay? And a lot of folks get confused and they think we're telling everyone else, you should be doing the same thing. No, We provide and we build these tools because we need to chase the millimeter to build that framework so that whoever you are, whatever our constituents and stakeholders need to do, our data has to be more accurate than it, okay? So just because we are chasing that millimeter, we're not saying you have to, but we will continue to do so for that rare customer who needs to, okay? Other thoughts on preparing. Again, know the epic of your data and your data sets. Consider how you'll track it. Maybe you will need a full to the second timestamp on every feature for something you're doing on a land resource analysis along the San Andreas Fault, right? But a lot of folks will probably get away with labeling a year for each data set, and you'll be able to use it far into the future or something in between. It's all up to you to kind of think about that, but don't hesitate to reach out to us for questions, guidance on that. More thoughts on preparing. Hopefully you'll transform your data using Ncat, or you'll check that whatever software you use is tapping into Ncat. Okay. Oh, here's a great question. I saw it. What is the difference between Ncat and CoreCon? I will say really quick to everybody there, please stop using CoreCon. I worked for the Corps of Engineers for about 10 years. It's a great product. I know the guy who built it. He's retired. And he would tell you, please stop using it. Don't use CoreCon. It hasn't been updated in 8 or 9 years, and it will not be updated. CoreCon, it was a great product, but Ncat has the N8083 2011 realization, and I missed a slide in there somewhere. I meant to point that out, those realizations. CoreCon doesn't have that. There's some other issues there. So I'll just say, if you don't understand why I'm saying please stop using CoreCon, reach out to me via email, look me up, and we can talk about it. But yeah, please get away from it. It was a great tool. Nothing, against the Corps of Engineers. But yeah, it's basically a dead product at this point. But hopefully it'll transform your data. Again, ask your software providers about integrating our APIs and whatnot, right? We've already done at least one industry workshop. I think there was a second, but we did one this year. And all the major well-known software makers were there. These were the folks I know were there, but there were more. There were like 7 or 9 different companies represented. But the big name players were there. Blue Marble is Global Mapper, if you don't know offhand. So that's how we envision that you'll be able to transform your data. Now, ideally, and which is what we will do, we'll be reprocessing a lot of our data. But for you to do that, that's a perfect world, right? It's a very complex task. What does it mean? Real quick, I'm going to pull these things up there. So for hydro-enforced DEM, as a final product, you need to start completely over with raw flight data, generate new point clouds, clean everything up, recreate all the drainage features in the new vertical and horizontal data, blah, blah, blah. Totally unnecessary, right? For most users, Another question I saw, so if all features are not collected at the same time, right, in a data set in a feature class, should we be collecting date with the position? Again, it really depends on your needs. Most people in the Texas area or anywhere outside of coastal California, you really won't need to do that. But GPS makes it possible, right? GPS is timestamp, time tagged. So if it's not hindering you and you can store that data that way, then sure, I'm going to jump to just a few additional resources, and I want to pop a few up while I take a look at the question about WGS84 and a couple other questions that flowed in. So I'll jump through a couple slides. Here's our Regional Advisor Program. There's our website if you want to take a look. I'm just going to take a look at this question here. So in regards to NextGen 911 and the vertical accuracy in location information, and that's actually a sticking point with some of our folks. I've been working with one of the working groups, NG 911 subcommittees or something through a Pennsylvania group. It's a Pennsylvania Emergency Management Agency. I can't really address your question there right now, sir, but there's two, myself and another NGSer, trying to get a handle on all the intricacies of the NG911 and 3D. The big catch is that effort, the intent is like a not just a United States, right? An international standard. And so that's where WGS 84 kind of came in instead of focusing on NAD 83. That's the most I can address the question right now. But if you want to follow up, drop me a line. Also, the regional advisor right down there in Texas, he's at the Texas Spatial Reference Center, a part of the Conrad Blucher Institute lab there at Texas A&M Corpus Christi. Whoop, there's his info, Dan. There's also a state geodetic coordinator in Texas at TxDOT, Randall Kircher, nice gentleman. Talked to him on the phone. There, let me skip these and go to these resources. Yeah, check these out at our website while I look at a couple other questions. Assume I collected data using NAD83 now, and then convert it to NatRef 2022 next year. How much will the data be shifted in 2030, taking into consideration the plate motion? If you're talking about in the Texas region, so in like 10 years, you're going to see like 20 centimeters off the top of my head. That's about right. I think about 20 centimeters of horizontal motion in about 10 years of data in Texas. And that's the whole goal of NatRef 2022, is to be able to hide that motion. So if you wanted, let's say you were looking at that data as somebody from the University of, I can't see where, maybe you wanted to quantify how much motion that was. You would keep that data in ITRF. But if you want to hide that motion and you want to have consistency, you'd use NatRef, you know?
Let's see, we got about 4 minutes left there, Jeff. Just if there's any other questions on here.
I think I hit him. The WGS 84 is a good question, and I'm sorry I can't answer it wholly. It's kind of under discussions between a few different entities. But reach out, again, if you want to talk more about it. And I'm just putting some more of our resources up here as we look. These are great resources, each educational videos. Our email subscriptions. If you sign up for the NGS webinar series, you will get the notification when our next webinar series comes out. This is going to be a good one for this user community, because Brian is another regional advisor. He's got a heavy background in ArcGIS Online and ArcGIS Server before that. He's going to walk through some of our really new resources, and to come too, some kind of future plan. So that'll be a good one. And we do those, I'm not sure if that's going to be the October or November webinar, but they're almost monthly.
Nice. No, this is great, Jeff. A fantastic presentation. I know it's a lot of data to cover, but I think you definitely made it a lot of fun. So it's and it's very informative. So what else do you have here? This is a mobile browser.
That was our, let me switch back. So that's our, if anybody that does geocaching and goes out and looks for the disks in the ground. So this is our new tool. It works on your Android or iPhone. You can find it real quick. Search here, search that phrase. It lets you find those marks, and you can submit recoveries. Some people I know do that, geocaching, and that's kind of new for us. It's been a long time coming, but it's been around for about 1.5 years now. So I still kind of put it out there, but we don't have any apps yet. We had to kind of focus on just mobile browser first before we get into any app development.
Well, very nice. Any other questions, Courtney? I don't think I see any more on here. If y'all have one, if you do think of something after the presentation ends, go ahead and email us or email Jeff. And if you email us, we'll make sure it gets to Jeff and try to get your question answered. We definitely appreciate everything that you've done today, and your presentation was fantastic. Looks like I saw about 104 and 105 people at the highest. I don't know if Courtney, you saw different, somewhere around there, which is pretty fantastic turnout. Saw a lot of names on here that are always coming to our speaker series. Jeff, by all means, please come back and attend some of our sessions. We definitely try to keep these presentations at a super high level that are informative, and so I'd look to see you again. But again, thank you. I'm gonna go ahead and give everybody a minute back of their day, at least by my clock. But Courtney, is there anything else going on?
And the recording definitely will be available on the Urissa, Texas YouTube channel.
Absolutely, absolutely. We're recording it, and we will have it posted as soon as we possibly can. And it's usually pretty quick.
Thanks, Jeff. Thanks, Brian. Appreciate
okay,
it.
Jeff, thanks a bunch, and we appreciate it. We'll see you all next month, and you all have a good rest of your day. Thank you.
Thanks, Brian. Thanks, Courtney.